My name is Megan Robertson, and I'm a professor at the University of Houston in the Department of Chemical Engineering. Our team is forming the Welsh Catalyst for Discovery Center for Plastic Circularity. Through this effort, we will develop new methods of recycling and reuse of plastic waste. Plastics provide enormous benefit to our society, but these benefits come at a cost. A very small fraction of plastic waste is recycled, and the majority ends up in landfills, is incinerated, or becomes pollution in oceans and on land. The class of plastics that we're targeting are polyolefins. These are materials such as polyethylenes and polypropylene that make up more than 60% of the plastics produced in the US and yet are recycled at low rates. We're going to enhance the recycling through a three-pronged approach. The first is to develop compatibilizers which can enable the recycling of mixed plastic waste. The second is to convert that plastic waste to useful products which are longer lifetime and more durable goods. And the third is to come up with new strategies to enable their circular reuse. One of the challenges that we will address is that it's difficult to recycle mixed plastic waste together. This is because most plastics don't want to mix with each other. It's kind of like mixing oil and water. In the case of oil and water, we use a soap. And what we are developing is a molecule called a compatibilizer that, like a soap, will bring together the plastics and allow them to be mixed together. This could eliminate the sorting and separation steps that are used currently in recycling processes, and also could enhance the properties and use of the recycled plastics. Another challenge that we'll address is that currently it's difficult to recycle plastics even just one time. However, that recycled product can still end up in landfills ultimately. We envision a different approach, which is to convert plastic waste to longer lifetime products, which can be used for years, if not decades. We'd like to convert polyolefin waste to thermoset polymers, which are used in a lot of different applications, such as foams, in construction and furniture, which will keep them out of landfills for a long period of time. One of the reasons that polyolefins are used in so many products is that they're very stable molecules. However, this stability has a disadvantage. If they end up in the environment, they can persist for many years. We would like to address this by bringing in new chemical groups into the molecules. This will enable us to break them down into smaller molecules and reuse them as new materials. Ultimately, this can be a circular process where the materials are formed, broken down and reformed, diverting them from landfill and from residing as waste. This project brings together an interdisciplinary team from both the chemical engineering and chemistry departments. In chemical engineering, we have myself, joined by Ramanan Krishnamurti and Alamgir Kareem. Our expertise is in polyolefin properties, functionalization, structure, processing, and importantly, recycling, upcycling, and circularity aspects. We are joined by Olaf Stavulis, Brad Carroll, and Maurice Burkhardt from the chemistry department. Their expertise is in the development of catalysts and ligands for catalysts for olefin polymerization. The group of faculty together can bring together careful aspects of molecular design where we can build the molecules from the ground up and then study how these novel molecules can enhance recycling and upcycling processes for polyolefins. Importantly, we will be joined by a large group of students and postdoctoral researchers. Together, we will all work together to tackle the challenges in polyolefin recycling.